Welcome everybody. We are ESE Team 13, Remote Ranger. I'm Carter, this is Rohan. Our last teammate, Will, unfortunately had a family commitment today, so couldn't be here, but I do promise you will hear his voice later in this presentation. So the first thing I want to ask you guys is, how many of you have heard of the story of 127 hours? Great, most of you. It's a story about a hiker named Aaron Ralston, who in 2003 went hiking by himself in Canyon National Park out in the west. And he didn't really notify anybody of his hiking plans. He thought it would just be a day hike, easy hike, get back, nothing much to it. But as he was descending in a slot canyon, the boulder he was on dismounted and trapped his right arm against the canyon wall. Now, if anybody knows anything about a slot canyon, you can't see anything out of it. Nobody can hear you, nobody can see you. Helicopters, satellite imagery, they're really not even going to see you either. So he was trapped in the bottom of the canyon, no way to call for help, by himself, alone. So how does the story end? Fortunately, he does make it out alive, but what he had to do was, after 5 days of very little food and very little water and beginning to hallucinate, he cut his own right arm off with the dull pocket knife that he had, rappelled 70 feet down the canyon, and found a Dutch family on vacation in the park. Now this part's important because had he left any earlier, he might not have encountered anybody, and when he found this family, they were able to call for help. His family also had alerted authorities that he had gone missing and they didn't know where he was, so they had a helicopter out looking for him at the same time. Had he left any later or tried leaving any later, he might have succumbed to his conditions and died in the canyon. But when this search party was looking out for him, they didn't know exactly where he was, so it was really the family being there, alerting the authorities that they found him, and already being out there. They didn't know exactly where he was, so they really would not have found him. So putting this into broader perspective of National Park Search and Rescue, which is the problem we're aiming to tackle, was 2004 to 2014, there were about 47,000 people that needed search and rescue in national parks across the US. And roughly 1,600 people died as a result of these incidents. This cost the national parks around $52 million. And as many of you may know, national parks are already strapped for cash, and their budgeting is really very tight, and they get very little money. Putting that in the perspective of 1 year alone, there are about 3,500 people as a result of 2,700 incidents in 2014 that needed search and rescue, and this resulted in about 160 people dying, and that cost the parks around $4 million. Thinking about national parks as a whole, there's about 300 million visitors each year across the US. This includes day trippers, backpackers, anybody entering and exiting the park gates at any point in time. So now that you know a bit of the background, some of the stories that this applies to, Rohan's going to go into more detail on the tracking system that national parks currently use.
Thanks, Carter. So right now, basically what happens when you go to hike in a national park is they'll give you a paper tag. On this paper tag, you'll have your name, your point of entry, and your intended point of exit throughout the national park. This serves as identification and like a permit, and basically it's just ID if they find you. As you can see, it's not an active device, right? It's just a piece of paper, and it's completely useless in the event of an emergency. So what do hikers do now? They use either GPS trackers or satellite phones. So a GPS tracker right now could help you figure out where you are and help you from getting lost. But again, in the event of an emergency, you're unable to reach out to anybody if you don't have cell service. On the other hand, a satellite phone would allow you to call from anywhere. However, in the event of an emergency, let's say you lost the phone, damaged the phone, or the phone was out of reach, so in Aaron Ralston's case, it's like you don't even have it, because if you hadn't made a call earlier, and there's no way for you to make a call after the event occurs, you're stuck. So our main objective here is to increase the efficiency of search and rescue operations. And we figured the best way to do that would be to make a device that pings your location and transmits it through a network to a ranger station, thereby kind of giving them an idea of where you are, where you've been, and like what your rate of progress is. So by doing this, we're hoping to have a significant cost savings for national parks by eliminating a lot of the time in search and rescue where they don't really know where you are. And more importantly, we're hoping to lower the loss of life. So for our device, we laid out a couple of specs. The first one is that we figured we'd ping the location every 10 minutes to ensure accuracy of where the hiker is. Additionally, we want the battery to last as long as possible, so ideally over a week to kind of cover the duration of most overnight hikes. We wanted an ergonomic and lightweight design that hikers wouldn't mind carrying. And finally, we wanted the device to have as long a range as possible, because the infrastructure in parks, we wanted to be minimalized so that the device would always be in service and the cost of the parks wouldn't be that high. So as you can see, we have a pretty compact design here that's pretty easily clipped onto a hiker's backpack, belt loop, whatever article of clothing they'd like to have. The dimensions of the device are 3 by 2 by 1, and it weighs under half a pound. So what we have is a GPS tracker And we decided to use an IoT network called Sigfox to transmit the data over to the ranger station. As you can see, this is the main board, and most of the processing is done by this Wisol quad-core module. This is powered by a 3.7 LiPo battery. And then what you can see next is the antenna we use to transmit over the Sigfox network. Carter's going to talk a little bit more about this later and the advantages that it has. Finally, we have the GPS tracker on the other side of the board. This is the antenna that it uses to ping the coordinates. And that's the summary of the device specs. So now Carter's going to talk to you guys about why we chose Sigfox, the design advantages it has, and a little bit more about the device.
Great, thanks, Rohan. So the very first thing we needed to do when coming up with this device design was choose the network that we're going to communicate on. So you think you're going to pull out your cell phone when you're hiking, that's kind of the go-to network you would use. But as you know, in national parks, you may get service, you may not if you're at the top of a mountain. More often than not, I don't find cell service when I'm out hiking. So there's a few different networks we could go with. One is a Wi-Fi based network, so you think you can get very high bandwidth, relatively good on power life, but the problem is you get a very short communication range. So if you're in a national park, you're going to need to set up receivers basically everywhere, and that's not very useful for our application. On the other side of the spectrum, if you think AM, FM frequencies, you get super long range and you can send a lot of data, but the power you need is quite high. So if you're going to ask a hiker to carry around a 4-pound battery, nobody's really going to do that, and we're not going to get the impact we need from this project. So we settled in the middle on a network called Sigfox. They operate on 900 megahertz. They have low bandwidth, but for our application, we're just sending GPS information, some battery life info, and a device ID, so we can do that all within the 12 bytes that they have on their specs. Additionally, we get the high individual range we need. So it's not as far as AM or FM radio, but at the same time, it's in the tens of kilometers range that we need. Going a bit more into detail, it's on a 900 megahertz, very resilient to noise, so the data that you try sending through will get through. And additionally, the low data payload allows for low power consumption. So the devices built on the IoT Sigfox network can last up to months at a time, and ours on our current model lasts upwards of 7 days. This device also has great device capacity. So that means that if you have 2,000 hikers going out or more in busy summer months all at the same time, you want to make sure that all their information can get through to the Sigfox backend, because you don't want data to be missing from any hiker, and this network can handle that. And as I mentioned, with the long communication range, we can get upwards of 50 kilometers in a rural environment, which is perfect for national parks. So looking at the device itself and how it works, it's centered around the Wisol Sigfox module that Rohan mentioned earlier. And GPS antenna brings in GPS data. Sigfox module parses that data from long decimal format into 6 bytes that we need to send to get your location down to basically 3 meters of accuracy, which we've tested and has been fantastic. That data then goes out on the Sigfox antenna to the Sigfox backend, and this is where the rangers come into play. That data is hosted on a AWS web server, which rangers can then go into our web app and see device ID, emergency contact info for a hiker that's been registered, their latest location, as well as their location history. So if you think about a hiker like Aaron Ralston, you could see his path leading up to his last communication point, and that's where you would go to look for him. And as I mentioned before, Will is going to have a voice in this presentation, and he's going to explain a bit of our web app now.
The Sigfox network allows us to set up a data forwarding service to Amazon Web Services, which we can store in a DynamoDB table for use in our platform. The versatility of this system allows us to scale the product both horizontally and vertically. Additionally, with the computing power AWS provides, we could later implement utilization reports on devices, trails, and the national parks themselves. Our web app gives rangers an easy-to-use interface and at-a-glance information. Rangers are easily able to register new remote ranger devices and register devices to hikers. These devices store all needed information about the hiker, such as contact information, destination, and an emergency contact. The device history can also be tracked, so rangers are able to get a history of their hiker's movements quickly and accurately using the Google Maps API. Rangers can pinpoint exact locations of users as well as a timestamp to see the path they are currently taking.
Cool, thanks, Will. So now moving into our power consumption, we were able to get about 2 weeks of battery life in temperate conditions out of our device. We're using a 1200 milliamp hour battery. And obviously the most power intensive things on this chip are the GPS and Sigfox functions. So as you can see, the GPS ping takes about 27 milliamps, and then transmission of these coordinates takes about 50. However, when the device is sleeping, which is most of the time, it has a very low power draw at only 1 milliamp, so we're able to stretch this battery out basically as long as possible. So kind of to investigate what the limits of the battery life were and how that trade-off is with the frequency of pings, we kind of mapped out basically what would happen if we pinged every 5 minutes all the way up to 3 hours. So as you can see on the one extreme for 5 minutes, if we were to ping the location of a hiker every 5 minutes, we would get a battery life of about a week. If we were to extend this to 3 hours, which is a little less precise than we wanted, we'd be able to make this battery last upwards of a month. So moving into the costs, right? We're trying to minimize the costs for national parks because basically they get grants for search and rescue, and they're not very, they are strapped for cash, as Carter mentioned earlier. The cost of manufacturing this device at scale, we figured, was $27, and then to host the web application is just $30 a month. Each device requires a Sigfox subscription in order to use the network. That's how Sigfox platform works. So this subscription cost is $1 per device per month. And we figure this is a very affordable price for national parks to pay, given the reduction in search and rescue time and cost that it will allow.
Great, thanks, Rohan. So bringing this all together at the very end, thinking about why this device matters, if you think about Aaron Ralston and his hike, the SOS went out from his family, but nobody knew where he was. So the Remote Ranger application, what this does, it allows you to know that the point where Aaron Ralston entered that canyon and then was then trapped afterwards is the point that you're going to go to. You don't need a helicopter to see him. You can use a helicopter to get to him. But hikers like him that end up in those situations where nothing's going to communicate out of a slot canyon and nobody's going to hear you, we can go to that exact location and it'll take mere hours to find and rescue anybody that becomes trapped rather than 5 days. So we hope that this application can apply to hikers stranded in scenarios and bring that death toll for search and rescue applications way down in the years to come, so that search and rescue not only is more effective cost-wise and life-wise, but that people can have much more peace of mind when they go out hiking in national parks in the U.S. So thank you guys, and are there any questions at this time? Yeah.
Can you talk a little bit about the $27? You said this would be at scale, so how would you get to scale? What would it cost you before then? And then the second question would be, who actually would get these in the national park? You talked about so many visitors. Would everyone get them? What would the screens be to decide who got the device?
Sure, yeah. So our prototype cost $70, I guess, because we bought a dev board and also like battery and other circuits. We've looked at the bill of materials, and we created a bill of materials and then basically priced it if they were to buy at volume, because pricing for a lot of these components is like tiered. So if you buy like 1 or 2, it's a lot more than if you buy 1,000. So that's what I meant by at scale, and that's kind of how we figured out that number.
And then going into who would get them in the national parks, it's mainly tailored towards people doing overnight trips. So I did a trip in spring break, and it was a few mainly day hikes. So everybody's within the same general area in the park. But there's people that go 10 miles out, like Aaron Ralston did. It was an 8-mile hike, I believe. So it's people that are staying overnight that go way out from the ranger station that could have endless possibilities of where they go. So those are the hikers that would mainly get them to be able to track them. Yeah.
Do you have to create infrastructure in the parks in order to have the signal transmitted?
You want to flip to this side?
Yeah. So the Sigfox network is based in France. So the blue regions on this map indicate coverage that they already have, and purple is where they're expanding to. So basically, almost anywhere in Western Europe, they have coverage set. And then in the US, they have major metropolitan areas covered already. But yes, to have this application, it would be focusing on developing the network in those specific areas.
We chose to develop on this in this new technology because they are trying to be an IoT platform, and they're catered towards developers. And because they're expanding coverage, we thought this would be very useful in the future, and it'd be good to be a first mover in this space.
Just to follow up, is there enough in the string to provide for something like a panic button for the device?
Yeah, so that's the next step in this application we would go to. So creating a button that would send out a different type of message, just a general SOS. So you have the general location of where the person's going. You get a special message that says, okay, we need to pay attention to this person now. They're struggling. So it'd be some kind of button on the device that you can't hit by accident. You'd have to purposely press it, but you have the same features we have now, plus that panic button to alert the rangers.
I mean, the way we'd
Yeah.
probably handle it would be 2 messages, right? We'd do location again, and then like, hey, we need help.
Yeah.
Yeah, so it's actually following the same thing, it had the same thought, but if you thought about making a different version, that's all it did, right? Because there are some situations in which they're passive, it has to be passive because they're passed out and unconscious. I would guess that the majority of situations are one where they can hit a panic button. You wouldn't have to transmit their position, they could just store the position over a period of time and then only transmit it. So you can make it lower power, lower cost, all of those things.
Yeah, so we actually, when we were kind of designing how best to approach this, we took that into consideration, but then we were thinking about an edge case or just a case where they weren't able to hit the panic button. So like, let's say that something happened and like the device got destroyed.
Yeah.
If the passive case would be able to help and the active case would not.
Yeah,
So.
we'd be able to get the cost way down so you could distribute a lot of these. I mean, I would guess most of the situations are not passive. And also, are they all waterproof and temperature proof?
But you thought the value was tracking the track.
Yeah, we thought that would cover most of, like, we chose to start there just in terms of covering our bases better. Yeah.
That's all the time we have. Thank you very much.
Appreciate it.
Thank you.